So we are moving ahead to 7.1, angles and angle measurement. So for this, we want to look at a general angle in standard position. And we know that an angle is a rotation of a ray about a fixed point. So when an angle is in standard position, the initial side is at the positive x-axis. The terminal side is the other ray that points outward within the quadrant. The vertex is at the origin at 0, 0, and the angle is listed between those two lines, those two rays. Notice that we have quadrant 1, 2, 3, and 4, and that's going to go counterclockwise. So for positive angles, the rotation is counterclockwise, and for negative angles, the rotation is clockwise. Quadrant angles are angles that fall on an axis. For example, those that fall on the x-axis are 0, plus or minus 180, and plus or minus 360. Those that fall on the y-axis are plus or minus 90 and 270. So these are your x-axis, and this is your y-axis. And those are called quadrant angles. So there are two different ways that we list angle measurements. We do degrees, and we use radians. And radians typically have a pi symbol involved. So if we want to convert from degrees to radians, we take the degree and we multiply by pi over 180. The easiest way to do this is take the degree and divide by 180, and then we'll attach the pi symbol on the end. We do not type the pi symbol in the calculator. We want to keep it in terms of pi. So for this one, we're going to take 45, divide by 180. That simplifies to 1/4. So we'll stick the pi up at the top. So 1 pi over 4, or we'll just say pi over 4. And that's the conversion. For example, 300, we'll take 300 over 180. And that simplifies down to 5/3. So that goes to 5 pi over 3. And that's my radian measurement. To convert from radians to degrees, we take the radian and multiply by 180 over pi. So typically, if we take pi over 3 times 180 over pi, the pi's would cancel, and that leaves you 180 over 3, which equals 60. 5 pi over 6 times 180 over pi. Pi's cancel. 180 divided by 6 is 30, so that gives me 5 times 30, which is 150 degrees. So that's how you convert between degrees and radians. So let's say we want to draw an angle in standard position. So the angle is 65 degrees. So we'll start here, and we'll just travel 65 degrees, and we know that's acute because it's less than 90 degrees. And we're going counterclockwise because it's positive. For negative 220, we go clockwise 220, so that's 2 quadrants, because each quadrant is 90 degrees. 270 would be the equivalent of 3 quadrants, and we go counterclockwise because it's positive. 5 pi over 4, if we converted this to a degree, that's 225 degrees. So we would go counterclockwise 225 degrees. For negative pi over 6, we'll convert this to a degree, and that's negative 30. So that's going to be down 30 degrees. And we're going counterclockwise. The negative pi is equivalent to negative 180. So that's going to be theta at negative 180 degrees. Coterminal angles are angles that share a terminal side, meaning they end in the same place. They're different values, but they end in the same place. So to find a positive one, you add 360 if it's in degrees, or you add 2 pi if it's in radians. To find a negative, you subtract 360 if it's in degrees, or you subtract 2 pi if it's in radians. Coterminal angles contain multiple rotations. So if we have theta equals 60 degrees, a positive coterminal angle would be 420 degrees. A negative one would be negative 300. We just add 360 or subtract 360. For 7 pi over 6, we're going to take 7 pi over 6, and we're going to add 2 pi. That's the same as 7 pi over 6 plus 12 pi over 6, which is 19 pi over 6. If we wanted a negative one, we'd subtract the 12 pi over 6, which gives us negative 5 pi over 6. Remember, you have to find a common denominator when you're dealing with fractions. Okay, so moving on. So the next says, find and draw an angle between 0 and 360. We're not going to focus on that because we're not concerned about drawing the actual angles. So the next thing we're going to look at is a reference angle. Angle B associated with angle theta, where B is an acute angle, meaning it's less than 90 degrees, formed by the terminal side of angle theta and the x-axis. So if angle theta falls in quadrant 1, then angle theta is equivalent to B, the reference angle. Angle B is your reference angle. Because remember, it's the acute angle formed by the terminal side and the x-axis. So if it falls in quadrant 2, this is theta. If it falls in quadrant 2, so this is my terminal side. And so this is the acute angle that's formed with the x-axis. If it falls in quadrant 3, this becomes my acute angle formed with the x-axis. In quadrant 4, this becomes my acute angle with the x-axis. So if that's the case, for the formula to find those things, so the reference angle here, they are the same, B equals theta. The reference angle for quadrant 2, B equals 180 minus theta. For quadrant 3, B equals theta minus 180. In quadrant 4, B equals 360 minus theta. And the way that works, so it says find the reference angle B for the given angle. Say we wanted to find the reference angle for 120 degrees. We know 120 lies in quadrant 2, so we do our formula for quadrant 2, which is 180 minus 120, so our reference angle is 60 degrees. For 53, that's quadrant 1, so we know that it is going to stay at 53 degrees. C, 948 degrees. So what you want to do is find the coterminal angle between 0 and 360. So we're going to take 948 and we're going to subtract 360 until we get below 360. So that leaves me with 588. I need to be below 360, so I'm going to subtract 360 again. And that gives me 228. So 228 is my coterminal angle. So we know that 228 is in quadrant 3. So we'll do 228 minus 180, which gives us 48 degrees. Same thing for negative 765 degrees. We'll add 360 until we make it positive. And so if you add 360 3 times, it takes you to 315 degrees, which is in quadrant 4. So 360 minus 315 gives me 45 degrees. And that's my reference angle. So pay attention to the quadrants, find the coterminal angle if necessary, and perform the correct formula and operation. Arc length. So an arc is the piece of the circle that is created by the angle theta. For example, this is the angle theta because it's where the arrow is located. So this is the arc that I'm trying to find. I want the length of that arc. Notice that the length of that arc is just a piece of the circumference. So what I'm going to find, I'm going to use this formula, is r times theta, where theta is measured in radians, not degrees. Theta is in radians, not degrees. So they give us theta here is 240 degrees. It's that inside angle. So theta is 240. So I need to convert that to radians. So 240 times pi over 180. So 240 divided by 180. That simplifies to 4 over 3. So 4 pi over 3. And now I'm just going to multiply that times 9, which gives me 36 pi over 3, which equals 12 pi. And that's my answer. And I'm going to leave it in terms of pi. For sector area, that's just the area of this shaded region. It's like finding the area of a slice of pizza or something to that effect. So A equals 1/2 times r squared times theta, where theta is also in radians. So if you're given degrees, we have to convert it. So we're going to convert this to radians. And we know that it's going to be 135 over 180 times pi, which is 3 pi over 4 once you simplify it. So we have 8 is my r because that's the radius, not the radians, but the radius. So 1/2 times 8 squared times 3 pi over 4. So that's 1/2 times 64 times 3 pi over 4, which is 32 times 3 pi over 4, which is 8 times 3 pi, which is 24 pi. And that's my answer for sector area. For the following examples, find the central angle, theta, in degrees, if the arc length is 71.5 and the radius is 13. So my arc length says S equals R theta. So S is actually 71.5, 13 times theta. So I'll divide by 13. And that gives me 5.5. Well, that's a radian measurement because my formula is in radians. So I need to convert this to degrees. So I'm going to take 5.5 times 180 over pi, and I'm going to type that in the calculator. And it gives me 315.127 degrees. All right, for the next one, it says the sector area is 302.6 meters squared, and the central angle is 120 degrees. Find the radius. So that means I have my area, 302.6 equals 1/2 r squared times theta, which is 120, but I need to convert it to radians. So 120 times pi over 180, and that's going to give me times 2 pi over 3. So I'm going to solve this for r squared. So I'm going to multiply both sides by 3 over 2 pi. Over 2 pi. And that's going to cancel that out. And that gives me 144.481. 1/2 r squared. Multiply by 2 on both sides to get rid of that. 1/2. And you get 288.962 equals r squared. Take the square root. And you get r equals 16.999. And finally, the last example. Find the area of the shaded region. So I need to find this area. So that means I need to find this whole sector area. So I'm going to convert the 100 to radians. So 100 times pi over 180 equals 10 pi over 18, which is 5 pi over 9, times 12 squared times 1/2, which is 5 pi over 9 times 72, which is 40 pi. So my sector area is 40 pi. Sector area is 40 pi. So now I just need to find the area of this triangle. Well, the area of this triangle can be found using the formula 1/2 AB sine theta, where A and B are the legs. So this is A and B. Well, A and B here are the same, so that's 1/2 times 12 times 12 times sine of 100. So we'll do that. And remember that if you're going to type sine of 100 in your calculator, make sure it's in degree mode. So that's 70.906. So I'm going to take 40 pi minus, so 40 pi minus 70.906, and that's going to give me the area that I'm looking for, which is 54.758. This formula is actually in 6.4, but we did not cover 6.4. So this formula is for the area of a triangle. When you don't know the height, you use 1/2 AB sine of theta, where theta is the angle between A and B. So area of a triangle, 1/2 AB sine theta, where theta is between side A and B. So just remember that. And that is the conclusion of 7.1. The information that you learned about the unit circle, make sure that you go to Embedded Math and get the full completed version of the unit circle. And that will be what you will use for the remainder of this course as we go forward.